Hi, and welcome to our 125th test and measurement video. Today, in part 2, we'll revisit the PICO PC-based Vector Network Analyzer, Vna. In part 2, we'll see how to perform a field calibration. This differs from the more comprehensive factory calibration performed on sensitive instruments such as the oscilloscope, spectrum analyzer, and Vna. Factory calibrations are typically done before the initial purchase and subsequently once a year or as required. They involve sending the instrument back to the manufacturer, where technicians open the enclosure, do whatever it takes, and certify that the equipment conforms to the original specifications. The Vna Field Calibration, in contrast, is performed by the user prior to each new set of measurements. It is performed entirely at a software level, without opening the enclosure, and it takes only a few minutes. It is often performed several times a day, whenever accurate measurements are required. PICO supplies this Calibration Accessories Kit, which has everything you need to do it. The user manual provides complete instructions. All calibration hardware and accessories come in this kit. First, of course, as shown in video 124, you must have downloaded the software from the manufacturer's website, www.picotech.com, and you must have installed it in your PC. Electrical connections must be completed. If accurate measurements are required, both the PC and the PICO Vna module should be warmed up for about a half an hour. The benchtop Vna is more expensive than either as oscilloscope or spectrum analyzer is, having comparable features. Expect to pay around $18,000 for a high-end Vna model, which puts it out of reach for most of us. However, PICO has recently come out with two PC-based Vnas. Their line of PC-based oscilloscopes are similar. These Vnas consist of totally enclosed modules with no external controls. They connect via USB cable to the user-supplied PC, into which PICO's instrument-specific software, free from the manufacturer, is downloaded and installed. The price break is possible because the instrument takes advantage of the PC's great processing and display capabilities. Since most individuals already possess a PC, that part of the cost can be left out of the equation. Notice in the diagram, to perform calibration, cables supplied by the manufacturer are run from port 1 and port 2 in the module to the device under test. PICO supplies two types of connectors that attach to the cables. They call them kits. If the insertable device under test has one or two male connectors, use female cables and identical male kits for both parts. Then, in the PC, open the PICO Vna software. In the main menu on the PC screen, select Tools and Calibration Kit. Click Load Port 1 Kit, insert the data for the Port 1 kit, and click Apply. Similarly, click Load Port 2 Kit, select the data for the Port 2 kit, and click Apply. The next step is to choose calibration kits appropriate for the device under test. If testing a non-insertable device under test with, for example, female connectors, use a single female kit for both parts in the Vna module. Now we move on to the next phase in the field calibration procedure, which is setting up calibration parameters. In the main window, click Calibration to open the calibration window, in which the following steps are to be performed. Set the sweep parameters. This is similar to setting up a spectrum analyzer. After setting bandwidth, apply values. Select the measurement required. Perform the calibration steps. Finally, click Apply Calibration. The bandwidth setting used during calibration largely determines the available dynamic range during the measurement. For fastest speed, choose 10 kHz bandwidth. Set calibration power to +0 decibels M. Set bandwidth to 140 kHz. For both best accuracy and about 100 decibels dynamic range, set calibration bandwidth to 100 Hz. Set calibration power to -3 dBm. Leave bandwidth set to 100 kHz during measurement. For general use, fast speed, about 90 decibel dynamic range, set calibration bandwidth to 1 kHz. Set calibration power to 0 dBm. Leave bandwidth set to 10 Hz during the measurement. For best dynamic range, set calibration bandwidth to 10 Hz. Set calibration power to +6 dBm. Leave bandwidth set to 10 Hz during measurement. In all cases, calibration averaging should be set to none. That's it for calibration. It seems complex, but after a few sessions, it will be very familiar. Thanks for watching. New videos are added periodically, so check back frequently.